How do we begin solving this equation containing fractions or rational expressions? We'll multiply through by the LCD, and here the LCD is x minus 1. Now don't forget that each term must be multiplied by x minus 1 in order to keep the equivalency. So it's x minus 1 times the first term x, and then minus x minus 1 times this term, 14 over x minus 1, is equal to x minus 1 times 4. Every single term is multiplied by x minus 1. So x minus 1 times the last term, 2x over x minus 1. And now let's see what happens. Here I have x times x minus 1. I'll just rewrite that. X times x minus 1. Here the x minus 1's divide out. Now be careful, that's minus 14 then, is equal to, I'll have 4 times x minus 1. I'll work on that in just a moment. And then these x minus 1's divide out, and I have minus 2x. Now let's remove parentheses and start solving. That's x squared minus x minus 14 is equal to 4x minus 4 minus 2x. Notice we have a quadratic equation. So how do we try to solve this quadratic equation? We move all terms to the left side and set it equal to 0. And I'm moving it to the left side since my x squared term is over there. So let's begin with that. I'll have x squared. Now you may want to take a few more steps, but notice I have 4x minus 2x, which is 2x on the right side. I will then subtract 2x from both sides, and negative x minus 2x, that's minus 3x. One more time, go ahead and take a step and combine these two terms. Those will be 2x. Then if I subtract 2x from both sides, negative 1x minus 2x is negative 3x. And then I have negative 14, and then I will add 4 to both sides, so I'll have minus 10 is equal to 0. Now what do? I factor, or I try and factor, that trinomial. I'll write x and x. Two factors of negative 10 whose sum is negative 3, that would be negative 5 and positive 2. And then remember, once we've factored on one side, we have 0 on the other side, we set each factor equal to 0, or x plus 2 is equal to 0. How do I solve this? I add 5 to both sides, so x is 5, or here I'll subtract 2 from both sides, x is negative 2. Now let's double check, but so far we have two proposed solutions, 5 and also negative 2. Will those be okay looking at our original rational equation? The answer is yes. The only value for x that would make the denominator 0 is 1. And notice neither of my proposed solutions is 1, so there I have my two solutions.